Welcome to Study Loop.
This is the answer to Chapter 17, problem number 43 from the Smith Organic Chemistry textbook. This problem asks us to draw additional resonance structures for each of these molecules. And so remember, we're going to do this by just moving electrons, whether it's lone pairs or double bonds or both. And so for A here, we can just move the electrons in our double bond. I guess I could have drawn that first one bigger. I'll draw the next two bigger. So that's going to put the double bond there, and it's going to put the radical here. And of course, technically, these are all the same structure because all of these carbons are really the same. You know, there's nothing to distinguish any of these carbons, but if any of them had substituents, it would be different. But really, if you want to be technical, these are all the same structure. And then we can just move the double bond like that. That's going to put our radical there and our double bond here. Okay, and so that's it for A. So B is pyrrole. And so this is actually going to be like two different sets. So the first thing that we can do is move our lone pair of electrons to here and move our double bond. Oops. It's important to draw the arrows exactly where you mean them to go. So our double bond, the electrons are going to go to that carbon. So the way that I had drawn it at first would have been indicating that we were making a new double bond. And of course, that's not the case. Okay, so we're going to have a positive charge on our nitrogen now, and a double bond there. And this carbon will have a lone pair and a negative charge. Okay, and so we can move the electrons again. So we can move these here, and these will go here. And so now we have a double bond here. We'll have a double bond here. Our nitrogen still has a positive charge on it. And our lone pair and negative charge are now on that carbon. Okay, so we can also do the same thing the other way. So again, starting from pyrrole. Oops, forgot my double bonds. So again, starting from pyrrole, we can do the exact same thing, just in the other direction. So these electrons can go here. These can go there. So now we'll have double bonds here and here. The nitrogen will have a positive charge, and we'll have a lone pair and a negative charge up there. And then we can move these again. So to here, and that double bond will break. And so now our nitrogen still has a positive charge, and now our lone pair and negative charge is on that carbon. Okay, and so lastly, for the phenanthrene, we're just going to be essentially just moving double bonds around in the ring. And so so at first, we can just move the double bonds in the leftmost ring. And so that will put us here. And so from there, we can move electrons like this. Oops. And let me move all of this down. There we go. Okay, so in our third resonance structure, and so I forgot to move these. There we go. Okay, so in our third resonance structure, we'll have this. Okay, and so we can also then move these bonds like this. So to here, to here, to here, to here, to here, and to here, and here. It's a lot of electron movement. Okay, and so the result of all those moves is going to be this double bonds in this configuration. Okay, and so lastly, we can just move these double bonds around this ring again. So when we do that, we'll be here and here and there. Okay, and so that's several more resonance structures for each of these. I believe it's all the resonance structures for each of these. And again, we got there just by moving electrons, which is how you make resonance structures. And that's the answer to chapter 17, problem number 43.